Hi everyone, so here we are, the very first lecture of second semester of the new year. We're going to start with chapter 13. So in chapter 13, we're going to talk about where the electrons are actually located in the atom. Okay, we know that from first semester, we know that the electrons are on the outside surrounding the nucleus somewhere, but we just know they're on the outside. We're going to find out more in detail where they're actually located. So before we do that, let's review our different models of the atom so that you can see the progression of where we are today. All right, so remember Dalton. Dalton was the first person to make a model of the atom, okay? And according to Dalton, he said that the atom was just like a solid mass. So we call this the billiard ball model. And then J.J. Thomson comes in. Remember, J.J. Thomson, he discovers electrons with his cathode ray tube experiment. So once he discovers the electrons, then next we have Rutherford. So remember, Rutherford is famous for his gold foil experiment. So he was testing whether or not J.J. Thomson's model was correct or not. So he took a piece of gold foil, he bombarded that piece of gold foil with a whole bunch of alpha particles. He expected all of those particles to pass straight through, indicating that the atom is made up of mostly empty space. But to his surprise, a small amount of those alpha particles were actually deflected back, indicating that we have a very small dense center, which we call the nucleus. So Rutherford discovers the nucleus, and we know that the nucleus has a positive charge. Okay, so far we have a nucleus, and we have protons and neutrons that are found in the nucleus, right? So let's just draw a picture of that. Okay, here's our nucleus. It's positive because protons or neutrons are in the nucleus. And then we know that on the outside somewhere are the electrons, okay, surrounding the nucleus. So the next person to add on to the structure of the atom was Niels Bohr, okay, Niels Bohr. He adds on this concept of energy levels. So you guys probably learned about energy levels when you're in middle school. Those are like the rings around the nucleus, okay? So for an example, if this is your nucleus, okay, sorry, that's a circle. There's your nucleus, right? So then the first ring around the nucleus is the first energy level. Then the second ring around the nucleus is the second energy level. And then you can keep going depending on what the atom is. Then the third energy level, and so on and so on. So it is important to know that in these energy levels, this is where we can find the electrons. They are in these energy levels, okay? And in order for an electron, so let's say we have an electron here. In order for an electron to jump up to a higher energy level, it has to absorb a certain amount of energy. And that certain amount of energy is called a quantum of energy. Okay? So once again, a quantum of energy is the minimum amount of energy needed to jump up to a higher energy level, like quantum leap. Okay, like quantum leap. Another important thing to know about the energy levels is that the energy levels are not equally spaced. Okay? As you keep adding on, so when you keep adding on an energy level, they actually get closer and closer and closer to each other. Okay, so once again, the energy levels are not evenly spaced. As you add on more energy levels, they get closer and closer to each other. So according to Bohr, he stated that yes, the electrons are found in these energy levels here. Okay, and that they basically go around in a circle orbiting the nucleus, okay? So that is based on Bohr's theory. And the ground state, so these are just some terms we're going to go over. So the ground state here is the lowest possible energy level. So the ground state for all atoms is going to be the first energy level. That is the lowest possible energy level. Then we have what is called the excited state. So the excited state is when the electron will jump up from one energy level to the next, okay, or to a higher energy level. So in order to jump up to a higher energy level, remember, it has to absorb energy, okay? It has to absorb energy, then it can jump up to a higher energy level. The model of the atom that we actually use today is called the quantum mechanical model, okay, quantum mechanical model. So we still use the concept of energy levels that Bohr brought in to the structure of the atom. But the electrons we discovered are not going around in a circle, okay? So they're not going around in a clear path, all right? They are actually in these clouds. The electrons are actually found in these cloud regions, and it's all based on probability and statistics. The probability of us finding an electron in the electron cloud region is about 90% of the time, okay? 10% of the time, it's outside of the cloud region. All right, so there's no exact path for the electron. It is not going around in a circle. It's bouncing around in that electron cloud, okay? So once again, based on the quantum mechanical model, the electrons are found in the electron cloud region, all right? And the probability of us finding the electron in the cloud region is about 90% of the time. Another concept that you need to know, these clouds, they have what are called orbitals, okay? Orbitals. And that's where we will most likely find the electron. And each orbital can have a maximum of 2 electrons, okay? 2 electrons into each orbital. So here's a picture of what an electron cloud could look like, okay, based on the quantum mechanical model. All the little speckles that you see here, all the little dots, okay, that is the probability of you being able to find an electron in this electron cloud region, okay? And the electron, once again, is not going around in a circle, orbiting the nucleus. The electron is actually bouncing around everywhere in different places, okay? It's just bouncing around in this cloud region. Once again, we can find the electron in the cloud region about 90% of the time. All right, so now we're going to get into more in detail of where these electrons are actually located in the electron cloud. So there are some terms that you'll need to know. N right here, the little n. In this chapter, this n represents the principal quantum number, which we call the energy level. Okay, so remember in chapter 12, the n represented moles. So in chapter 13, the n represents energy level, or what we call the principal energy level, or sometimes principal quantum number. And these energy levels are broken down into what we call sublevels, okay? Sublevels. So the sublevels I have listed down here, these are the letters, okay, of the sublevels. And these sublevels represent the shape of the cloud, okay? The shape of the cloud. And we're going to go through and talk about all these different sublevels and their shapes. So they all begin with the letter S. Sublevel, okay? S, P, D, and F, and shape. So they all begin with the letter S. Then these sublevels are broken down into what we call orbitals, okay, orbitals. And remember, each orbital can only hold a maximum of 2 electrons, all right, 2 electrons into each orbital. And so the orbitals basically tell us the orientation in space, okay? So orbitals will tell us the orientation of the electron cloud. So both of those begin with the letter O. And we're going to go through each one and talk about them in more detail. All right, so the first one we're going to talk about is an s orbital. All right, the s orbital. The s orbital is spherical in shape. So basically it's round, all right? So every energy level has an s orbital. And so this begins in the first energy level and beyond. So basically every energy level has an s orbital. And there's only one type of s. All right? There's only one type of s orbital. So if there's only one kind of s orbital, how many electrons can you fit into that s orbital? 2. Okay, you can remember, you can only fit 2 electrons into each orbital. Then the next type of orbitals we're going to talk about are the p orbitals. The p orbitals are shaped like peanuts. So you can see how some of these letters will help you remember the shapes and stuff. So p, right? And this is p here. And that represents a peanut. And go back, look at the S one, right? S for the S sublevel here. Okay, spherical. So P, which is a peanut shaped, type of orbital is found in, well, first, it starts in the second energy level, okay? So the P's are going to come in the second energy level and beyond, all right? And there are 3 different p orbitals. One along the x, one along the y, and one along the z-axis. So these are 3-dimensional, all right? They are 3-dimensional. So there are 3 different p orbitals, and therefore, how many electrons can fit into each one? Well, remember, 2 electrons into each orbital, so then that's a total of 6 electrons, okay? 6 electrons. So you could fit 2 electrons in this one, 2 electrons in that one, and 2 electrons in that one. So that's a total of 6, okay? So let's review this page first. So far, we have the s orbital that is spherical in shape, and there's only one type of s orbital, so therefore we can only fit 2 electrons there. Then we have the p orbitals that are peanut shape, and these are found in the second energy level and beyond. So every energy level, we're going to be adding on a different sublevel, all right? So the first energy level can only have an S. Then the second energy level will have an S and a P, okay? So once you find the P's coming into the second energy level, there are 3 different P's, all right? There are 3 different p orbitals, all right? And then now, let me show you what they look like. So right here, these are your S's. Notice they are spherical in shape. The one in the front there tells you the energy level, okay? So this is telling in the first energy level, this is what the sublevel, the s orbital, will look like, spherical in shape. The 2 here means for the second energy level. So in the second energy level, the s orbital is also spherical in shape. Notice the difference in size, okay? The second s orbital here in the second energy level is larger because you're adding on an energy level. Okay, notice it gets larger. Also in the second energy level, remember, we have the p's that come in. All right, one along the y, one along the x, and one along the z there. See, you can see that those look like peanuts, okay? Peanuts or figure 8s. So you can fit 2 electrons here, 2 electrons there, and 2 electrons there. So remember, the electrons are found in these electron clouds. These are the shapes of the electron clouds. So you have 2 electrons bouncing around in this cloud, 2 electrons bouncing around in that one, 2 electrons bouncing around, and then 2 electrons bouncing around in that cloud. All right? Now we're going to talk about the d orbital. So the d orbital looks like a 4-leaf clover. Okay, the majority of them look like a 4-leaf clover. And the d orbital will come in the third energy level and beyond. Okay, and there are 5 different d orbitals. So then if there are 5 different d orbitals, what is the total number of electrons that you can find in the d? Correct, that'll be 10. Okay, then we have our f orbitals. All right, the f orbitals here look like flowers. So f and flowers are the same. The f orbitals come in the 4th energy level and beyond. And there are 7 different f orbitals. And then how many electrons can fit into the f's? Remember, 2 electrons into each one, so that's a total of 14 electrons. Okay, so if you noticed, there is a pattern. So the s orbitals, there's only one type of s orbital, right? The p's, there are 3 different p orbitals. The d's have 5 different orbitals, and the f's have 7 different orbitals, okay? So you see the pattern? 1, 3, 5, 7. 1, 3, 5, 7. Okay? So remember, this is all based on probability and statistics and mathematics, so you're going to see these patterns. So 1, 3, 5, 7, S, P, D, and F. Okay? All right, now here's a picture of what the D's and F's look like. So the D's are on top. Okay, notice that most of these look like 4-leaf clovers, but then of course this one looks a little different, kind of looks like 2 pacifiers stuck together. So notice there are 5 different D's. 2 electrons in each one. So 2 electrons bouncing around in those clouds. 2 electrons bouncing around, 2, 2, 2. Okay? Then the pink ones down here at the bottom, these are your Fs. Most of them do look like flowers, all right? And these look a little different. So once again, these are the electron clouds. The electrons are bouncing around in these electron cloud regions. Okay, so 2 electrons into each one bouncing around. All right, so let's summarize a few more things here. So remember, first energy level only has an S. Second energy level, we add on the P's. Third energy level, we add on the D's. And then the fourth energy level, we add on the F's. Notice the number. The number of sublevels equals the energy level, right? There's only one sublevel there in the first energy level. The second energy level has 2 sublevels. The third energy level has 3 sublevels. And the fourth energy level has 4 sublevels. All right, so once again, you just keep adding on a sublevel every energy level. All right, so read these 2 questions. We're going to review and see if you can figure out these answers on your own. So pause the video, answer the questions, and then play the video, see if you got it right. So the first question, what's the maximum number of electrons in the first energy level? Okay, so the first energy level, let's think about it. Do we have an S in the first energy level? Yes. Do we have a P in the first energy level? No. Okay, the first energy level only has an S, and that's it. So then the question is the number of electrons in the first energy level. So therefore, let's think it back again. How many different s orbitals are there? There's only one orientation for something that's spherical, right? So there's only one orbital, and then therefore, how many electrons can we fit into that orbital? 2. Okay, so the answer is 2. All right, the next question. What is the maximum number of electrons in the second energy level? Now, this is where it gets a little tricky, okay? So in the second energy level, ask yourself, is there an s orbital in the second energy level? Yes. Is there a p orbital in the second energy level? Yes. This is where we add on the p's. Is there a d orbital in the second energy level? No, okay? Only S and P's in the second energy level. All right, then how many different orientations or orbitals does an S have? Only one type of S, right? Which means that is equal to 2 electrons. And then how many different p orbitals are there? There are 3 different p orbitals. And then you can fit 2 electrons into each one. So that's a total of 6 electrons. So you're going to add these up together. And then that's how you will get 8 electrons in the second energy level. Okay, so one of the handouts that you have is a blank periodic table. So on your blank periodic table, I want you to label it like this, and I want you to color code it also. Okay, so you need to label. So you need to label the things like here where it says like 3D, 4D, like that kind of stuff. You know, all of those things. You need to label those and then color code it. You don't have to pick these exact same colors. You could pick different colors just as long as you have them grouped correctly. All right, so make sure you take some time right now and color code that blank periodic table that you have.